Yes, so after discussing to you the basics about the quark flow diagram, let me now move forward to the Zweig rule. Now what is Zweig rule? As you can see, I have already written it down here for your convenience. You see, it is a very simple rule, and what does it say? The Zweig rule, or sometimes it is also called OZ rule. তিন জনের নাম আছে, 3 scientists, their name. So together it is also called OZ rule, or sometimes only one of them is named Zweig rule. What is the rule? This rule states that processes which correspond to disconnect quark line diagrams are inhibited. This means they are very difficult to happen. What is important is disconnect line, quark line diagram. Till now, whatever examples I have shown to you, they were continuous. There was no disconnection between the quark line diagrams. Kintu er poroborti kale, right now, what I will show you through examples will be cases where the diagrams will be disconnected, and so such reactions do not happen. Okay? Or it is very difficult to happen. You can think of it like that. So a diagram is now, what do you mean by disconnection? A diagram is disconnected if one or more hadrons can be isolated by a line which does not cut any quark lines. Okay, er maneta ki hocche? Let me now see. You see, the first example is the figure is shown in figure 5.32, the first example. You see, here I have shown to you the quark line diagram showing omega to pi plus, pi 0 and pi minus. Omega, again, first jeta korte hobe, what I have to do is I have to remember the quark constituents of this particle. So omega, you see, it consists of u and tu. Now I am using the quark flow diagram. How do I represent u? Left to right arrow, fine, horizontal arrow. Next, anti-u, right to left, horizontal arrow. Now you see, this omega will create 3 particles, pi plus, pi 0 and pi minus. Right, now you see this diagram here, how beautifully you can create it. Again, this will be happening at a very high energy. Okay, you see how? So basically what is happening is there is creation of 2 pairs of quark anti-pair, quark anti-quark. One is D and anti-D quark, jeta pi plus e jabe. Again arekta hoye jabe D and anti-D quark, again jeta pi 0 te jabe. So here in this, through this quark flow diagram, we are basically showing the creation of 2 pairs of D and anti-D quark. Any questions for this example of figure 5.32? This is very simple. So you see, there is no disconnection. Ekhane kono osubidha nei. No disconnection. Very simple diagram. Let me now show you the next figure. What is the next figure? The next figure is again the figure 5.33, which is the quark line diagram showing phi to k plus and k minus. Again you see the same old story, phi, which has the constituent of S and anti-S quark, right? Now again it is being shown by this S quark, horizontal left to right, and for anti-S, horizontal right to left. And you see here, in this case, this quark flow diagram would not have been possible without the creation of 1 pair of U and anti-U quark, right? And when you create that, you put the U quark in one place and anti-U quark in another particle, and this way you can create 2 particles. So far there is no problem. এখানে কোনো disconnection নেই, কোনো অসুবিধা নেই. Fine. Now let me move forward to the next figure, which is figure 5.34, and this is the first case which says that this reaction is not possible, and I am showing this here without giving you any physics details. এটা কেন হচ্ছে না এর আমি physics details তোমাদেরকে দিচ্ছি না. I am just showing you why is this not possible through only the ZWEIG'S rule. Okay, maybe in future class I will discuss about the reasons, but right now let me concentrate on the reason through the quark flow diagram only. The first thing দেখো যেটা হচ্ছে, the first thing to note that is, সবাই শুনতে পাচ্ছে তো? Okay, the first thing to note that is দেখো phi, the left hand side of the reaction is phi, right? Now phi has constituent S and anti-S. Good. But on the right side of the diagram there are three particles, pi 0, pi plus and pi minus. Interestingly, you see that in none of the cases there is an S quark. ठीक तो? Pi 0, pi plus, pi minus, in three of them there is no S quark. Now how can you create from phi to these three particles? How can you create them? Because remember, if you have to create, the S and anti-S quark must be there somewhere. But here, you cannot connect them because the pi plus, pi 0 and pi minus, they don't have any S quark with them. And so this causes the disconnected quark line diagram, which you can see there. Any questions? This is a very simple example which shows the disconnected quark line diagram. And as a result, this process is inhibited by the ZWEIG'S rule. Okay. Now,